Right now, you're moving faster than a jet fighter, and you don't even feel it. At the equator, Earth's spin carries you at over 1,600 kilometers per hour. But what if, for just 5 seconds, that motion stopped dead? Your body wouldn't stop with it. Neither would the oceans, the atmosphere, or every loose object on the planet. In an instant, the air itself becomes a supersonic wind tearing across continents. The oceans surge forward, forming walls of water taller than skyscrapers. Buildings shear from their foundations. Anything not bolted down, cars, trees, people, is hurled eastward at the speed of a rifle bullet. And this happens everywhere on Earth, all at once.
This is what physicists call inertia, and it does not negotiate. Isaac Newton described the rule more than 300 years ago, long before anyone imagined it would ever be tested at planetary scale. An object in motion stays in motion until something forces it to stop. For 5 seconds, the ground beneath every living thing on Earth has just been forced to stop. Nothing else got the message. Think of the lurch of a car braking hard. Your body keeps moving forward even after the seat stops. Now scale that same simple physics up to an entire planet, and to everything living on its surface, all at the exact same instant. That's the entire disaster in one sentence. Everything else is just the aftermath of that one broken rule, playing out across every continent at once. Start with the air. At sea level, sound travels at roughly 1,235 kilometers per hour. The wind now scouring the Earth's surface near the equator moves faster than that, somewhere around Mach 1.3. There has never been a hurricane, tornado, or typhoon in recorded history that came remotely close. The most extreme sustained winds ever measured in a hurricane peaked at just over 300 kilometers per hour. This wind is more than 5 times that. But here's what most people don't expect. The destructive force of wind doesn't scale in a straight line with its speed. It scales with the square of it, which means this isn't 5 times more destructive than the worst storm ever recorded. It's closer to 25, maybe 30 times more destructive. Even scientists modeling scenarios like this describe the numbers as almost difficult to process, and the intensity of that wind depends entirely on where you happen to be standing when it happens. Near the equator, across places like Ecuador, Indonesia, or the Amazon basin, the full force of that supersonic mismatch arrives all at once. Closer to the true poles, the effect fades dramatically because the ground there was barely moving to begin with. A research station sitting almost exactly at the South Pole would feel barely more wind from this specific effect than on an ordinary day. Everywhere in between falls somewhere along that spectrum. For the first and possibly only moment in this disaster, geography, not preparation, not luck, decides how close to total annihilation any given place actually comes. Cities engineered to survive earthquakes, floods, and direct hits from major hurricanes were never designed for a force like this. Windows don't shatter, they disintegrate. Trees aren't uprooted, they're erased. Steel-frame skyscrapers, some of the most over-engineered structures humans have ever built, begin to fail at their foundations, torn apart by a wind no building code on the planet ever accounted for. And the wind is only the first messenger. The water hadn't even arrived yet. Every ocean on the planet surges forward at once, carried by the exact same momentum that just tore the sky apart. Researchers who've modeled scenarios like this estimate wave heights that could rival or exceed the tallest skyscrapers on Earth, though the true scale remains genuinely uncertain, since nothing in the geological record offers a real comparison. What is far more certain is the timing. This isn't a wave that takes hours to build and travel, the way a tsunami triggered by a distant earthquake normally does. It rises everywhere, instantly, on every coastline on the planet, from Lagos to Los Angeles to Jakarta, within the same 5 seconds. And while entire coastlines vanish beneath walls of moving ocean, a very different disaster is unfolding thousands of meters above them, where there's no higher ground to run to. Every aircraft in flight, the moment rotation stops, finds itself suddenly flying through air that no longer behaves the way air is supposed to. The atmosphere around each plane is still moving at the planet's old rotational speed, meaning an airliner cruising calmly over open ocean is instantly hit by wind shear beyond anything any aircraft has ever been built to survive. Aviation engineers who study extreme turbulence events tend to agree on one grim point. There is no design margin for a force like this. It isn't a bumpy flight. It's structural failure, thousands of meters in the air with nowhere to land. Strangely, the one place mostly insulated from the chaos is space itself. Satellites stay in orbit because of gravity, not because they're bolted to the spinning Earth beneath them. So in the truest physical sense, the stop doesn't touch them directly. But that safety turns out to be almost meaningless. The ground stations, data centers, fiber optic lines, and cell towers that turn a satellite signal into something a phone, a hospital, or a power grid can actually use are being destroyed in that same instant, on every continent at once. The satellites keep transmitting perfectly. Almost nothing left on the ground is in any condition to listen. But here's a detail almost nobody accounts for when they picture this event. The disaster doesn't necessarily end when the 5 seconds do. If Earth's rotation resumes exactly where it left off, snapping back to full speed just as suddenly as it vanished, then the entire catastrophe repeats itself, in reverse. The ground beneath the wreckage, the water, and the survivors accelerates forward again, out from underneath anything that never regained that momentum. Objects thrown one direction moments earlier now appear to slam backward against a surface suddenly moving beneath them once more. It's the same physics, the same inertia, simply running the other way. Instead of one catastrophic mismatch in momentum, the planet may end up absorbing two, only seconds apart. Deep underground, meanwhile, a different kind of violence has already been building. And it exposes something real about our planet that most people never think about. Earth's outer core doesn't rotate in perfect lockstep with the mantle and crust above it. Geophysicists have measured a small natural drift between them for decades. In this scenario, that ordinarily tiny drift becomes catastrophic. The crust stops instantly. The layers beneath it, still carrying the planet's old momentum, do not, at least not at the same moment, and not uniformly. Scientists modeling this kind of stress agree it would likely trigger earthquakes beyond anything in the historical record, rupturing fault lines that had sat quiet for centuries, and quite possibly waking volcanic systems along the way, from the Pacific's ring of fire to fault networks that had shown no warning signs at all. And on the surface, inside the wreckage of collapsing cities, an entirely new danger begins to spread. One with no wind, no wave, and no warning of its own. Ruptured gas lines meet damaged electrical systems. Fires ignite across fractured cities simultaneously, with no functioning fire departments, no working hydrants, and no way to call for help, because the same 5 seconds that destroyed roads and buildings also destroyed the power grids, cell towers, and undersea cables. Modern life quietly depends on every single day. For the first time in generations, entire regions of the planet go completely, totally silent. Not by choice, simply because the infrastructure connecting billions of people no longer exists. Somewhere beneath all of this, human beings are trying to survive an hour that nothing in their lives prepared them for. The rule, if there even is one, is brutally simple. Get underground, get away from the coast, and get away from anything tall enough to fall on you. Basements, subway tunnels, and reinforced interior rooms become the difference between life and death. Anyone caught outdoors during those first seconds has almost no realistic chance, not from bad luck, but because the physics of the event leaves no real room for survival above ground. Families are separated in an instant, decisions get made with no information and no time, and for those who do make it underground in time, the ordeal is only just beginning to unfold. When survivors finally emerge hours later, they don't recognize the world they left behind. Smoke, ash, and pulverized debris hang so thick in the sky that daylight looks like dusk in regions thousands of kilometers from the nearest disaster zone. Temperatures swing unpredictably as the planet's disrupted air currents struggle to find any kind of balance. Coastlines have physically moved. Landmarks that stood for centuries are simply gone. It isn't only that the world is damaged, it's that entire mental maps of what a coastline, a skyline, even a horizon is supposed to look like no longer apply. For a while, the acute chaos begins to fade, replaced by something quieter, slower, and in some ways even more dangerous. Farmland near almost every coastline on Earth is gone, buried under seawater that could take years to fully leach from the soil, if it ever does. Ports, the arteries global trade depends on, are wrecked beyond recognition. Water treatment plants fail as power stays offline indefinitely, and without clean water or intact medical supply chains, disease begins moving through survivor communities faster than any government or aid network can respond. It turns out the most dangerous part of a catastrophe like this often isn't the moment of impact. It's everything quietly downstream of it that has to keep working, and suddenly doesn't. Then, almost invisibly, the climate itself starts to shift. Dust and aerosols thrown into the upper atmosphere by simultaneous earthquakes, fires, and coastal devastation can block enough sunlight to measurably cool the entire planet for months, possibly years. The same basic mechanism at a much larger scale behind the historical year without a summer that followed the 1815 eruption of Mount Tambora. Except this time the trigger wasn't one volcano on one island. It was almost the entire surface of the Earth, disrupted within the same handful of seconds, and the deeper waters of the planet may never fully return to what they were before. The mega tsunamis don't just crash and recede, they redistribute staggering volumes of ocean water and heat in ways that could permanently disturb currents like the Gulf Stream or the Kuroshio, systems that quietly regulate the climate of entire continents. Some climate scientists modeling this kind of disruption suggest regions that were once mild could shift dramatically colder or hotter, depending on how those currents eventually settle, a process that could take decades. Long after the physical wreckage has already been cleared away, years later civilization still exists. But it doesn't look like it used to. Coastal megacities are abandoned or slowly rebuilt further inland, a project so vast it spans generations rather than years. Populations migrate away from the coastlines that once held most of the world's largest cities, reshaping borders, economies, and cultures in ways that ripple far beyond the original disaster. Agriculture adapts to new climate zones. Aviation, shipping, and global communication are rebuilt almost from scratch, engineered around hard lessons learned from a planet that, for 5 seconds, stopped behaving like anything in human history ever had. To put the scale of it in perspective, even the worst natural disasters in recorded history, the 2004 Indian Ocean tsunami, the 1906 San Francisco earthquake, the eruption of Krakatoa, struck one region, one ocean, one fault line at a time. Timeline 247 doesn't. It strikes every coastline, every fault line, and every square kilometer of atmosphere on Earth within the same 5-second window. There's no historical playbook for a disaster with no unaffected regions left standing to send help. So could humanity actually recover from something like this? Most researchers who study large-scale catastrophic risk tend to agree on a cautiously hopeful answer. Yes, eventually, though not everywhere at the same pace. Landlocked and higher altitude regions, spared the worst of the tsunamis, would likely rebuild faster than coastal nations forced to relocate entire populations. Our species has come back from ice ages, pandemics, and civilizational collapse before, and history suggests we're remarkably good at rebuilding, given enough time. But recovery here wouldn't mean restoring what was lost. It would mean constructing something new on top of the wreckage, with different coastlines, a different climate, and a far harder won understanding of just how fragile stable really is. What makes timeline 247 so unsettling isn't really the 5 seconds of stillness at its center. It's everything that refuses to be still along with it. Every drop of ocean, every gust of wind, every human body, still obeying the laws of motion the planet itself just broke. We spend our entire lives standing on a spinning world without ever feeling it move, trusting a stability so total we forget it's even there at all. Maybe that's the real question this timeline leaves behind, long after the screen goes dark. How many of the forces quietly holding your world together right now are things you've never once had to think about, until the exact moment they stop? Somewhere in the timeline room, that Earth is still suspended in the impossible half-second between motion and stillness. Ours, for now, keeps turning.